Okay, did you practice the last question? Last question. Question number 13. Last one. After question number 12, we did question 13. I made a request to calculate at 4. Let's first take the mean value, mean and standard deviation. There are two companies which produce medical tablets to provide vitamin C to patients. Doctors say that both tablets consist of equal content of vitamin C and no difference between the two tablets. Following information is given. Test this statement. Right. Company 1, company 2, milligram given. How many data? 2, 4, 6, 8, 10. Right. Now, according to this data, you know how to calculate mean and standard deviation, but using scientific calculators, take mean and standard deviation. No need to waste time. You can calculate x bar, x1 bar, x2 bar. At the same time, take standard deviation 1, standard deviation 2, using your calculators. Right. I use my ST mod here. Right. Take 20 equal 21. I use ES calculator. 21, 18, 18, 22, 17, 19 times, then 20. I take my mean and standard deviation. X bar 19.5 in company bar. What is the standard deviation? At the same time, I calculate SX for 1.581. Right, that is first company. Then I take second company 22, 17, 19, 21, 17, and again 17, 20, 18, 21, and 19. X bar 19.1. I know that some of you have done. X 1.852. Two decimal points also enough, right? I then define null hypothesis. H naught mu1 equals mu2. Otherwise, no difference between company 1 and company 2. Alternative hypothesis mu1 not equal mu2. You know, in body, no difference between two companies. Alternative, there is the difference. But notation over the notation is enough. Take your acceptance and rejection regions because of a small sample. You know, T table we have to apply. 0.475 acceptance region. 0.025 rejection region. Center point 0. Take your degrees of freedom to sample N1 plus N2 minus 2. 10 plus 10 minus 2, 20, 18 degrees of freedom. At 18 degrees of freedom, using T table 0.025. Then check 0.025, 18 degrees of freedom, 2.101. 2.101 minus 2.151. Right. You can check whether your answer is correct. Then I need to calculate test statistics. Test statistic x1 bar minus x2 bar. Because of a small sample, the approximate standard deviation multiplied by 1 over n1 plus 1 over n2. Initially, you calculated SP n1 minus 1 is 1 square plus n2 minus 1 is 2 square divided n1 plus n2 minus 2 square root approximate standard deviation. First sample size 10 minus 1. What is my standard deviation? 1.5881 square. Plus second sample also 10 minus 1. 1.852 square divided 10 plus 10 minus 2 square root. That value should be between the two standard deviation, which are 1.581 and 1.852. In between your SP, if you have done correctly. 1.581 squared into 1.852 squared. Need to divide by 10 plus 10, 2. minus 2. 18. Square root of that 1.721. You can see this in between 1.721. Now calculate test statistics. X1 bar 19.5 minus 19.1 second mean. Approximate standard deviation 1.721 multiplied by 1 over first sample size, 1 over second sample size. That is your test statistics. Right. Calculate. Zero 0.519. 0.519. Maybe slightly changes if you use different decimals. 0.519, is it correct? Right. The answer is correct. Then you can check this belongs to any acceptance region. Acceptance region. Therefore, you can see H not accepted. Two companies which produce medical tablets to provide vitamin C to patient. Doctors say that both tablets consist of equal content of vitamin C. Yes, the statement is correct. Right. Right. Now we write our step 5 conclusion. You know how to write, but we write test statistic belongs to acceptance region. Test statistic belongs to acceptance region. H naught is accepted. H naught is accepted. Right. Further, if you want, you can say a statement of the doctors is correct. But H naught is accepted, that is sufficient. But further, the idea is statement of the doctors is accepted or the statement of the doctors is correct. Because vitamin C equals content. When you take the mean 19.5, 19.1, normally happening in the production. This is happening normally. Purposefully, companies have not reduced the vitamin C content. Right. At the moment, all the descriptive statistics you have completed. Right. From the introduction part, methods of sampling, we finished our introduction part. After that, we came to data organizing part. Array frequency distributions. Then we organize the data. We organize the data. After that, we present the data using graphical presentation, histogram, frequency polygon, frequency curve, cumulative frequency curve. Then we started the analysis. Prior to that, I discussed sigma notation. Isn't it? Right, sigma notation. Then descriptive statistics. Under the descriptive statistic, we have completed measure of central tendency, measure of dispersion, measure of skewness, measure of curvature. Then we completed estimation. Estimation of population mean, estimation of the difference of population mean. Then hypothesis test for population mean, hypothesis test for difference of population means. Okay. Right, I remember, you also remember. Then we want to start next one, correlation and regression analysis. Correlation and regression. correlation and regression analysis. Correlation and regression. Correlation and regression analysis. Correlation and regression analysis. Right. सहसंबंधता सह प्रतिपादन विश्लेषण. सहसंबंधता सह प्रतिपादन विश्लेषण. Correlation and regression analysis. Regression analysis, you can say regression models as regression models because we construct models. First, we want to study correlation. After that, we have to come to the regression. Right? Correlation. Correlation means correlation analysis. That is the relationship between the variables. What is the relationship between the variables X and Y? That relationship you want to identify. Relationship. Whether the relationship is positive, whether the relationship is negative, whether the relationship is zero, that is no relationship, you want to identify. We know in organization or businesses, price and demand, negative relations. Price and supply, positive relations. Higher the price, higher the supply. Less price, less supply. But demand, high price, less demand, less price, high demand. So like that, you want to identify the relationship between the two variables. This may be positive, negative, or zero. The decision you want to take. Always correlation analysis, we take two variables at a time. Many variables you can analyze, but two by two. Therefore, this is called bivariate analysis. Bivariate analysis. Descriptive statistic only one by one. One variable, one variable we analyze separately. That is a univariate analysis. But this is two variables always. Therefore, bivariate analysis. Your objective is to identify the relationship, whether it is positive, negative, or zero. In organizations, you want to apply that correlation analysis. Right. First idea we write down. Relationship between the variables. Relationship between the variables is called correlation. Is called correlation. Is called correlation. To identify the relationship, between the variables, correlation analysis is applied. Correlation analysis is applied. This is the bivariate analysis. The bivariate analysis. Bivariate analysis. As we consider two variables, as we consider two variables, as we consider two variables at a time, at a time. This is called bivariate analysis. This is called bivariate analysis. Relationship may be positive, negative or zero. Positive, negative or zero. Relationship may be positive, negative or zero. Right, in your organization everywhere, right? Manufacturing, service, or transport, hotel industry, any field you can apply. When you apply, first you want to understand one by one, right? Then take some headings, positive relationship. Positive relationship. Positive relations. Right. Positive relationship means same direction is followed by both variables. When the value of one variable goes up, the value of another variable also goes up. Similarly, when the value of one variable comes down, the value of another variable also comes down. How you identify? Later we calculate coefficient of correlation denoted by simple R. Coefficient of correlation. Saha sambandhata samguna. Based on the value of that, if the value is plus, we take decision, there is a positive relationship between the two variables. Right, we write down. If the same direction is followed, if the same direction is followed, by the two variables, the same direction is followed by the two variables, that is called positive relationship. That is called positive relationship. This means that when the value of one variable goes up, the value of another variable also goes up. Similarly, when the value of one variable comes down, the value of one variable comes down, the value of another variable also comes down. Coefficient of correlation people are right, coefficient of correlation will be positive. Coefficient of correlation will be positive. R value positive. Example, Relationship between price and supply. Relationship between price and supply. Employees training and productivity. Employees training and productivity. Like that, you can take more variables. Salary and employee retention. High salary, high retention. Employee promotion and satisfaction. Better performance, they are having promotion scheme, then they are satisfied. Like that. Coefficient of correlation will be positive because when you take the variable x goes up, y also goes up. Similarly, when the value comes down, y also comes down. Right? Same direction. From this, you can identify the relationship that is positive. Then we take negative relations. Negative. Opposite side. Negative relationship. Negative relationship means different directions are followed. When the value of one variable goes up, the value of another variable comes down. Price and demand. High price, less demand. Less price, high demand. Employee satisfaction and labor turnover. High satisfaction, less turnover. Less satisfaction, high turnover. Negative relationship. Right. Now we write down. If the same direction is followed, by the two variables, if the same direction is followed by the two variables, that is called, if the same direction or if the different directions, not same direction, if the different direction, the different directions are followed by the two variables. Sorry, if the different directions are followed by the two variables, that is called negative relationship. That is called negative relationship. This means that when the value of one variable goes up, when the value of one variable goes up, the value of another variable comes down. The value of another variable comes down. Coefficient of correlation will be negative. Coefficient of correlation will be negative. Because x variable value goes up, then y variable comes down. Or maybe it's come down, it's going up. Different directions, right? Example, relationship between price and demand. Right, relationship between price and demand. So, normal goods. Relationship between price and demand. Employee satisfaction and labor turnover. Employee satisfaction and labor turnover. High satisfaction, less turnover. They are explained in the company. High satisfaction. So likewise, you can see negative. Then we want to take no relationship Otherwise, zero relationship. Zero relationship. This means that no association between the variables. When the value of one variable change, no association with the change of another variable. No any effect to the change of another variable. X variable increase or decrease. But why? No any change. Therefore, no association between the two variables. Coefficient of correlation will be zero. Null hypothesis is developed based on coefficient of correlation zero. Zero, null. Null hypothesis. In hypothesis test, later we do. Okay, right. Now we write down. If the change of one variable, does not have any association, with the change of another variable, that is called zero relationship. Coefficient of correlation will be zero. Coefficient of correlation will be zero. R equals zero. Because no any change. X maybe goes up or comes down, change. No association. Example, unrelated variables. In the world, we can see unrelated variables. Number of accidents in front of cell, right? And size of your lunch bag. No association. If there are more accidents, do you have high dinner or high lunch? Lunch bag and take a If you are having different relationship, yeah, we can say there is positive relationship. No accidents, my lunch packet is very big. There is a relationship. Unrelated variables. That's why null hypothesis we develop based on null hypothesis. Based on zero, no relationship. Right. Number of accidents in UK and number of accidents in Sri Lanka. No relationship. Theater full of. But you can check. That's why you are doing research. Right, now how we can calculate, identify. For that purpose, we want to first calculate coefficient of correlation. Then take subheading coefficient of correlation. Regression analysis we take later. Coefficient of correlation. Right. Relationship we can test by using coefficient of correlation denoted by simple R. If your calculation is correct, always this should be between +1 and -1. You cannot take any value beyond this range, +1 and -1. If you take another value, that is the mistake done by you, right? Greater than +1 or less than -1, that is your mistake. This is the value. Based on R value, you can identify the relationship. Positive relationship, negative inverse relationship, negative, zero means no process. That decision you can take based on coefficient of correlation. Right, now we write down relationship between the variables. Relationship between the variables is calculated by coefficient of correlation. Coefficient of correlation. Coefficient of correlation. This is denoted by simple R. This is denoted by simple R. Always the value will be between. Always the value will be between -1 and +1. -1 and +1. -1 and +1. But in notation, you can write like this: -1 less than or equal simple R less than or equal +1. Between -1 and +1. As a parametric technique, we apply all Pearson's coefficient of correlation. Coefficient of correlation. Statistical packages are provided as Pearson. Pearson is Carl Pearson. COK both you can use. Carl Pearson's coefficient of correlation. Statistical packages provided Pearson's correlation. That is this parametric technique. What is the meaning of parametric? Parametric and parametric techniques. Parametric, non-parametric. The difference. I discussed types of data: nominal, ordinal, interval, ratio. Nominal, ordinal, non-parametric. Interval, ratio, apply parametric. The difference between these two: parametric. Yes, the thought is correct. But the population is normally distributed. That assumption is there in parametric, isn't it? Sanghane Pramadaya කියන assumption එක තියෙනවා නේද? Oh, in parametric. Right. The difference is population is normally distributed. Assumption is there parametric. Non-parametric, that assumption is not there, isn't it? The difference take it on. Otherwise, you can say parametric techniques, no N, no N. But parametric, non-parametric, N, no N is there. That is also correct. Isn't it? Okay, therefore keep in mind, you have learned thought. Step by step, we are coming to the end. Right, Carl Pearson coefficient of correlation. We apply, right? Right, then continue. Formula is given below. Formula is given below. Right. Many times in research, we apply this Pearson correlation. Right, very powerful. Right, formula, coefficient of correlation are X and Y, two variables. n sigma xy minus sigma x sigma y. Because x and y, two variables, divided by n sigma x squared minus sigma x totally squared. For the y variable also you do the same thing, n sigma y squared minus sigma y totally squared. And the denominator part is square root. Right? Very simple formula. Only x and y. One variable assume as x, another variable as y. Okay. Right, then we can practice. Now take this question number 1. That this handout is with you. Compute the coefficients of correlation and identify the association between promotion program expenditure and sales income. Promotion expenditure in 1000, sales income also in 1000. 2000, 3000, so on, 50,000, 60,000, 60,000, so on. I want to identify the relationship between these two. Looking at this data only, you can't take decision. You want to calculate. After you calculate coefficient of correlation, you can take a decision. Right. Now, let's practice coefficient of correlation. I take my data set. Right. Now, promotion expenditure, I take as X, sales income as Y. Because independent variable, promotion expenditure. Sales income will depend on promotion expenditure. Therefore, X promotion expenditure, Y sales income. 2, 3, 4, 4. Next one, 5 and 6. Fifty, 60, 60. 80, 90. 80, 90, 80. Okay, now you want to calculate coefficient of correlation. Keep space to the right side for the calculation. Then I use my formula. I write here R equals n sigma xy minus sigma x sigma y. That formula I use. Right. Then take necessary data from your data set. Can take data. N is what? N means number of observations. Number of observations pairwise. Pairwise. නිරීක්ෂිත ගණන යුගල වශයෙන්. Number of observations pairwise. X and Y both we take one pairwise. 1, 2, 3, 4, 5, 6. In these things. Right, then you know R in these things multiplied. Sigma XY. First multiply X and Y. 2 into 50, 100. 3, 6, 80. 180. 4, 24, 240.00, 32, 320, 0, 545, 50, 60, then 848, 480. Sigma XY means summation of this column. 0, 8, 10, 15, 19, 27, 2 left, 4, 8, 10, 13, 15, 17. Okay, check. 1770 is incorrect. So, 15, 27, 2 left, 10. Right. Right. Sigma XY 1770 minus sigma X multiplied by sigma Y. Then I take summation of this column sigma X 3, 5, 9, 13, 18, 24, 24. Sigma Y summation of this column 0, 9, 17, 10, 25, 30, 36, 40, 42, 420. Check whether the values are correct. 24 multiplied by 420 is 420 correct. 17, 20, 25, 30, 36, 40, 42. Correct. Divided by n 6 sigma x squared. X squared means another column. X squared column. 2 squared 4. 3 squared 9. 4 squared 16. 16. 5 squared 25. 6 squared 36. Sigma x squared is that summation. 9, 13, 19, 20, 25, 30, 36, 3 left, 3, 6, 9, 10, 106. I obtained 106. Check whether my calculation is correct. 106 correct. Sigma x squared 106 minus here sigma x totally squared. Sigma x 24, 24 squared. Right. N 6 multiplied. Sigma y squared. If it is first you want take square of y. Now I take y squared. The column. 00 5 squared means 25, 2500. This is 3600. 3600. 8 squared 64. Another 6400. 81, 8100. 64, 6400. Then take sigma y squared. 0, 0, 4, 5, 9, 10, 15, 20, 26 to left, 8, 10, 16, 20, 22, 25, 27. 30,600. Check whether the summation is correct. Sigma Y 420 start. Because we know sigma Y squared, sigma Y total is squared, not equal. It is. Sigma notation we learn. Sigma notation. Right, now simplify. Right, numerator I do 6 into 1770 minus 24 into 420. 540 I obtain. No need all these steps, but you can solve. Right, then I multiply 6 into 106 minus 24 squared, 60. Multiply 6 into 30,600 minus 420 squared, 7,200. Square root. Right, I multiply 60 multiplied 7,200. Then I take the square root of that. Then 540 divided by that answer 0.821. Right? Question of correlation 0.821. So be between -1 and +1. Now you can interpret the result. There is a positive relationship between promotion, program expenditure, and sales income. Promotion, program expenditure, and sales income. That's a positive. Right? Right. Now we write interpretation. There is a positive relationship. There is the positive relationship between promotion program expenditure and sales income. Promotion program expenditure and sales income. That is the interpretation. But further, if you want to take decision in your research, your business decision, whether the relationship is perfect, or strong, or average, or weak, that type of decision also we can take based on this value, right? We can take further decision. Therefore, write down. If we need to interpret the relationship, further, we can use following guidelines. Right, if your R value equals +1, we say perfect positive. perfect positive relations. Oh, totally the change of one variable has influence in another variable. Perfect. When one unit is changed, another also changed by one unit. That is the positive relationship. Perfect. If the value is 0.7 or more, is strong positive relations. This value up to 0.5 average positive relations. If the value less than 0.5, weak positive relation. All these we take as positive. All these we take as positive. Then negative also we can write if your R equals -1, perfect negative relations. R less than or equal -0.7 is wrong. Mathematically, you know, inequality sign should be written another way. -0.8 is strong. -0.8, -0.7. But this is strong, more than this. But mathematically, this is less. That's why symbol in this way. If the R value -0.5 or less, average. R greater than -0.5, weak negative relations. All these we take as negative. If R equals 0, that is no relations. No relations. That is taken as 0. Even though you interpret whether the relationship is positive, negative or 0, it's enough. But further, if you want to interpret, you can use this guideline. That is the guideline. Right. Now, what can you say according to this value? 0.8 to 1 or more than 0.7. Therefore, there is a strong positive relationship. Strong positives. But in research, it is sufficient positive relationship. But further, if you want to interpret, you can say strong. Right. Therefore, under that write down, according to the guidelines, there is a strong positive relationship. There is a strong positive relationship between promotion program expenditure and sales income. Promotion program expenditure and sales income. Right, the strong relationship is there positive. Okay. Any clarification so far? Right. In the scientific calculators, this Cartesian correlation is given. R is given in RVG mode. RVG mode. Regression mode. At the moment you are aware, normal operation deg mode, descriptive statistic as D mode, O1 minus variable, and correlation regression we use REG mode. REG mode. Okay, right. Which calculator you are having? Both, no? Right, MS calculators. Right, MS calculators, press the mode key. When you press, you can see REG modes. REG. MS calculators. Right, what is the number? Right, press that number, number 2, REG mode. Okay. Yes, calculators there. Press the mode key, then you can see statistic mode. ES calculators, press the mode key, then you can see statistic mode. Then A plus BX option. Right, number 2. Right, that is correlation. If the ES calculators, in your ES calculators, 2 columns there. Sometimes 3 columns there, maybe if it is, it should be frequency one. Right. Enter data. 2 equal, 3 equal, 4 equal, 4 equal, like that, enter data in ES calculators. MS calculators, you are having lin. Lin is the linear option. Lin. Press that number. Press that number. Right. Now you are right in REG mode. Then enter your data. How you enter data? 2 x. Pairwise we have to enter. Comma is there. Calculator comma is there. If it is not deleted, it is there. Then 50 y value m plus key. M plus key. Then display indicates 1. Right. 1. That is first data point. Then 3, 6 tm plus 4, 6 tm plus, like that data. All the data. Display indicates 6 if you have entered all the data. Right. MS calculators you finish. Right. After that, right, both ES MS calculators, if you have finished entering data, press AC key. Now you cannot see anything. Now then we start taking correlation. MS calculators, MS. Press shift, then number 2. Press number 3. Okay, in your calculator, cursor key is there. This side. Press this cursor key to come to the right. Arrow එකක් තියෙන එක. Use this one. Then you can see ABR. 1, 2, 3 option you can see. When you press this cursor key right side, ABR you can see. This is your Carl Pearson correlation. Press number 3 equal sign. You can see relationship between the variables. Okay. Okay. Right. ES calculator. ES calculator, when you press AC, after that, shift and number 1. Let's shift number 1. Then you can see REG another option. REG option. What is the value? REG option, you can see the value is 2, 5. Press that number. When you press that number, you can see REG. Then press that number equals 0.81. Okay. Okay, normally you have to clear your mode. No, ES calculators, mode key composite, number 1. Image calculator, shift mode, number 2 equals mode will be clear. We familiar. Mode take a clear करके दरअसल दिए. Otherwise, you can calculate correlation only at the exam. Right. In the correlation analysis, you can take decision here, but we do not know the hypothesis of this. After testing the hypothesis, you can take better decision, not just in the value. Even though this is 0.8 to 1, null hypothesis is accepted, we say no relationship. Because null hypothesis, no relationship. Alternative, there is a relationship. Testing hypothesis, you can take better decision. Remote decision can't do test the hypothesis. Right, therefore, subheading we take hypothesis test for correlation analysis. Hypothesis test for correlation analysis. Hypothesis test for correlation analysis. I brief note write down. Even though there is a value, for the coefficient of correlation, we have to test the hypothesis. We have to test the hypothesis to determine the relationship. Use the following steps to determine the relationship. Use the following steps. Step 1, define null hypothesis. H naught R equals 0. That is no relationship. Right, when you test the hypothesis, you obtain null hypothesis accepted. Irrespective of this value, you say no relation. That is step 1. Step 2, define alternative hypothesis. Are not equal 0. This means that there is a relationship. It may be positive or negative. There is a relationship. Step 3. Decide the level of confidence or significance. Decide the level of confidence or significance. And identify critical values. And identify critical values. Then decide acceptance and rejection periods. Then identify acceptance and then decide acceptance and rejection periods. Decide to identify acceptance and rejection periods. If T table is used, decrease of freedom is given by n minus 2. Because x and y, two variables we use. Degrees of freedom is given by n minus 2. You know how to take, right? Hypothesis, you are familiar. Acceptance region, rejection region. T table when used, degrees of freedom n minus 2. From that you can take critical values. Acceptance region, rejection region. 95% confidence, 5% significance. No need to explain more and more, right? You feel that dull and monotonous, isn't it? You are familiar with this. Therefore, no need to explain further and further. Step 4. Calculate test statistic. Calculate test statistics. Right. From this you can decide. Coefficient of correlation are divided by 1 minus r squared over n minus 2 square root. This is my standard error. Denominator part is standard error. Right? This is the coefficient of correlation test statistics. R1 minus r squared over n minus 2. Right. Step 5. Take the conclusions. 0.82 of R on this value. Take the conclusion. Test statistic belongs to acceptance region, H not accepted, no relationship. Test statistic belongs to rejection region, H not is rejected, there is relationship. Right, now we write, if test statistic belongs to acceptance region, H naught is accepted. No relationship between the variables. H naught is accepted. No relationship between the variables. If test statistic belongs to rejection region, H naught is rejected. There is a relationship. between the variables. Between the variables. Right. That's the way we define null and alternative hypothesis. You can take better decision. In your research, you do like that. In your organizations, when you test relationship, you apply hypothesis. Okay, now do this. Now you can test. Coefficient of correlation 0.821. Now I am going to test this hypothesis. Null hypothesis R equals 0. Alternative hypothesis R not equal 0. What is this? Here, no relationship between promotion program expenditure and sales income. According to my exercise. Here there is relationship. There is a relationship. Right, now I take my acceptance and rejection region. 95% confidence, 0.475, 0.475, acceptance region, 0.025, 0.025, rejection regions. I use T table because here 6 observations. Then degrees of freedom, n minus 2. 6 minus 2 means 4 degrees of freedom. T table 0.025 I use because my table is having significance. One side significance is there. Then take T table 0.025, 4 degrees of freedom, 2.776. Minus 2.776. 4 degrees of freedom. Okay. Calculate test statistic. Test statistic R over 1 minus R square over n minus 2 square. R is 0.821 divided. 1 minus 0.821 square over 6 minus 2 square root. Two point 876. I obtained 2.876. Is it correct? Right. Then take decision. 2.876. This belongs to this side. 2.7. 2.876 means outside. Rejection rate. H naught is rejected means there is relationship. Then you can say there is a relationship, significant relationship. That's why in research we say significant relationship. That is a positive relationship, is strong positive. Now you can take better decision. Even though this is 0.8 to 1, your test statistic belongs to acceptance region, you say no relationship. Right, now we write interpretation. Conclusion. Conclusion. Test statistic belongs to rejection region.
So get the 2.816 in the calendar.
Yeah, in the calculation I did. I used the calculator. That's how I did. 1 minus 0.821 squared, right? Equal sign divided by 6 minus 2 means 4 equal square root sign of answer equal then 0.821 divided by answer equal. Very easy, no? Practice the calculator, right? Calculator product the practice level. Right. What we did, test statistic belongs to rejection rate. Only that. Rejection rate. H naught is rejected. H naught is rejected. H naught is rejected. This means that there is the relationship between the variables. There is the relationship between the variables. Then you can say at 0.821 that is positive and strong, right? Right. Now we write down further. As the coefficient of correlation, you can write R as the coefficient of correlation is 0.821. As the coefficient of correlation is 0.821. There is a strong positive relationship. There is a strong positive relationship. There is a strong positive relationship between promotion program expenditure and sales income. Promotion program expenditure and sales income. Right. Now, when you test by using statistical package, that is called significant relationship. Significant relationship. The significant relationship factor again, right? Within bracket to write down, there is a significant relationship. There is a significant positive relationship. There is a significant positive relationship. Right now, statistical package when you use, no need to refer standard tables, T table. What? Later when you practice, you can use statistical packages provided the value P value. That is the probability. It is called P value. Otherwise, we call significant factor. SIG. Statistical package is provided in another one as SIG. Only SIG. Significant. Significant means P value. Probability. That probability, when you take that probability, it means that your test statistic belongs to rejection region. Here, from that to outside area is given as SIG. Outside area probability is given as SIG. Significant. P value. You take the same portion belongs to here. 2.876 minus 2.876, both provided as C. Now, when you take P value less than or equal 0.05, what happened? දෙකේම එකතුව 0.05 හෝ ඊට වඩා අඩු වුණොත් මොකද වෙන්නේ? Test statistic belongs to rejection rate. Therefore, statistical packages of a decision if p value less than or equal 0.05, H not reject. H not reject. If your p value more than 0.05, H not accept. Accept. Statistical packages, we take decision using that. When you use a statistical package, you can have. But you don't want to calculate this p value. Why? We are having test statistics. The statistical packages, when you use, you can use, but at the examination, we are going to test that p value less than or equal 0.05. If test statistic belongs to rejection region, p value is less than 5%. If it belongs to acceptance region, what happens? From that to outside, p value more than 5%. Isn't it? Are in here? Right, there must have the but I believe that you understood. Statistical packages when you use SPSS, EVUs, Minitabs, tests, whatever the program. Yes, this is not there.
Okay.
Right, that's the way we take decision. But the p value, you don't want to calculate this p values. His value we can calculate again by using normal distribution function. I mean p value calculate කරන්න significant value. Statistical packages are calculating accordingly. But we don't want to do that. Normal distribution function probability, that is R, as the significant. When you calculate 1 minus R squared over n minus 2 square root multiplied by 2.5 e to the power of minus half R over 1 minus R squared over n minus 2 root the power. Now p value, right? Statistical package they calculate. If the value is less than 5%, it's not rejected. More than 5%, it's not accepted. It's right now. No e value is absolute that value, right? 2.7. 28459045. Just down. 503.1. ඔය values දශමස්ථාන 15යි 9යි දාලා calculate එක යන්නේ statistical package. ඔයගොල්ලන්ට කරන්න පුළුවන්. 2 point values ටික දාන්න. minus of R 0.821, 1 minus 0.821 square, and 6 minus 2 square R 5. Very simple. Calculation में जुटा क्या ना एक तरह p-value. Okay, right. But instead of that, you are using test the statistic. Based on that, you can take decision. Okay, right. That is the relationship. You can mean this one. Where are your test the statistic from that to outside probability? From that. But you don't want to do p-value as you are having test statistics. Now, infinitesimal. තවත් ඉවර වෙන්නේ නැහැ. Infinite. අපිරිමිත. What do you think? You think what happened to us? Right now, correlation is that relationship. From that onwards, we want to move to test the effect regression model, regression analysis. Now we take some heading regression analysis. Regression analysis. Regression analysis. Regression analysis, otherwise actually models. Regression models. Right, this means that X and Y relationship. You want to test effect of X on Y, effect of sales, effect of promotion expenditure on sales income. We want to test. Correlation analysis, relationship. Regression models, effect, impact, බලපෑම. Therefore, not only one variable, more variables effect you can test. What is the effect of price on demand? What is the effect of income on demand? What is the effect of price of other products on demand? Like that you can test. Right. For that purpose, we use regression models. To identify the effect of the variables, we construct a model equation. That is a linear line. That's why RBG option, MS calculators, you can say linear effect. We write a model. The model is y equals beta 0 plus beta 1 x1, beta 2 x2, beta 3 x3. Like that we can write the model. Finally, we write error. Don't worry about error. Later I explain error. Those. This is the model. Then your objective is to calculate beta 0, beta 1, beta 2, beta 3, these values. Then you can construct your model for the data. In your organization, there may be a lot of data. You can construct models. Right. Briefly write down like this. When we construct an equation, to test the effect of one or more variables on another variable. That is the regression model. effect within bracket impact or influence. Effect within bracket impact or influence, right? Effect of variables can be tested by regression models. By regression models. We use linear regression models. Linear regression models. Linear regression models. Linear regression models. Right, another name, CLR. That is classical linear regression model. Classical linear regression model. Classical linear regression model. Gaussian model. It's also Gaussian model. Gaussian model. The OLS model. OLS. An ordinary least discount. Ordinary least discount. Ordinary least discount. අඩුතම වර්ග ක්‍රමය කියලා කියන්නේ. අහලා ඇති. ඔව්. ඇහුවා දැන්. නේද? Right. Ordinary least discount. OLS. Good with the norm. The linear regression model. We use. Linear regression model. Right. Regression models can be classified. Simple regression model, multiple regression model. You want to learn both, right? Simple model as well as multiple model. Correlation analysis always pairwise, 2 by 2. The correlation analysis again, in your correlation analysis relationship X and Y, but you do not know whether the relationship is coming from X to Y or Y to X or both direction. We don't know. But there is a relationship. Right? But further, if you want to identify whether the relationship is coming from X to Y or Y to X or in both directions, another test you want to apply. That is the Granger causality. Granger causality test. But Granger causality test is not in your syllabus. Therefore, I am not going to discuss Granger causality, whether X causes Y, Y causes X, or X causes Y and Y causes X. That is unidirectional Granger causality, bidirectional Granger causality, and independence of variable. Without the Granger causality, take a narrow. Later you can study, right? Right here, linear regression model we study linear. Many times in research, we apply linear regression model. And continue your note. Regression models can be classified. Regression models can be classified. Regression models can be classified as follows. First one, simple regression model. Simple regression model. Second, multiple regression model. simple regression model, multiple regression model, simple, सरल इकाई, बहुगुण इकाई. Right, first we take simple model, right. Simple regression model, simple regression model. सरल प्रतिपादन simple. What is meant by simple regression model? Simple regression model means only one independent variable. Always in the model, one dependent variable. Simple or multiple. Simple regression model, we are having only one independent variable. Simple equation you have written. I know that y equals a plus bx. Simple model. You know y equals mx plus c. Linear line. Linear. This way or this way, whatever, that is linear. Then if I write y equals c plus mx, same thing. So here a is what? Intercept or constant. Near the intercept. Antapattu. No, right? Intercept. V is my slope. That is the gradient. Wave. Anukramani. Slope or gradient. Objective is to calculate A and B. This slope or gradient and the constant, if you calculated, your model is finished. But for the data, this data, you want to calculate A and B. This is slope, gradient, or trigonometry you have done, no? Trigonometry, tan theta. That is tan theta. Right? How can we Right. Derivative, first derivative. Following your right? Intercept and slope, gradient. You need to calculate this one for the data set. But to calculate for the data set, what is the method we use? We use OLS. Ordinary least discount method we apply. They are always use OLS. When you read articles, right? Or in magazines, business papers, OLS you can see. OLS means linear regression model, ordinary least discount method. Adutama varga from. Based on that, we construct model. Right, simple regression model we write down like this. If the model is having only one independent variable, that is a simple regression model. That is a simple regression model. That is given below. Y equals a plus bx. This is constant. This is b, slope or gradient. Even though you write this one as y equals beta 0, beta 1 x, yes. Y is your dependent variable, x is independent variable. Y dependent variable, x independent variable. Promotion expenditure independent, sales dependent. Then we want to calculate constant and slope for the data. Then your model will be finished, right? Based on that, you can go for forecasting. Forecasting. You cannot forecast without identifying A and B to the existing data. Right. For the write down, when we calculate intercept and slope, when we calculate intercept and slope, model can be constructed. For the data. After that, model can be used for forecasting. Using ordinary least square method, OLS. Using ordinary least square method, OLS. Model is constructed. Use the following steps. Model is constructed. Use the following steps. Step 1. Write the simple regression model. Using X and Y. Y equals A plus Bx. First you want to write like this. Wording, if you write Y means sales A plus B promotion expenditure. Using X and Y we can write, otherwise using words your variable you can write. Normally using X and Y we write, at the end after we construct the model we write using word, sales, promotion, expenditure. That is step 1. Step 2. Right, this model you apply sigma notation to both sides. When you apply sigma notation to OLS, right? Sigma notation, you can obtain first normal equation. You can obtain first normal equation. That is step 2, write down. Apply sigma notation. To the model. We can obtain normal equation 1. We can obtain, apply sigma notation to the model. We can obtain normal equation 1. Right, now apply sigma with model. Y, when you apply sigma, that is sigma Y. apply sigma here. A, that is the constant, not variable. Then when you apply sigma, according to a sigma knowledge, sigma notation, what is this? Constant. I discussed C, Cx. Constant eකට sigma damma. Oh, sigma C. Sigma C equals NC. Right? Sigma notations I discussed. 5 rules මතකයි. sigma rules කතා කරනකොට මම කිව්වා I said that again I take this sigma notation in correlation and regression. You remember? I said that I take again sigma notation in correlation and regression. At that time you thought that okay, no problem, you take. Because you have to keep in mind sigma C equals NC. Cx equals C sigma x. Remember? Sigma notation වල බලන්න. Constant. Then variable is multiplied by a constant coefficient. Then addition, subtraction, power of a variable, and multiplication of variables. You know what I mean? You know what I mean? Sigma notation මුල් ඉඳලම තියෙන එකක් තියෙනවද මම හරියට පොත තියෙනවද ඒක ප්‍රසන්ටේෂන් වලින් පාතේ බලන්න on 1, 2, and 3. Sigma Cx, sigma x. Sigma C and C. Sigma x. Right there. Put all money. ini බලන්න වෙලාවක් නැහැ රිසීට් එකේ දෙකයි. Right, sigma C NC Zx. Then when you apply sigma Zx C sigma x. Right, මෙතන දාන්න එනවා. Y sigma y a constant Na Vx B sigma x. For the first equation, first normal equation. To follow this sigma notation, this guideline, many variables, hundreds of variables if you have, model can be constructed. Model එක ඔන්න ගන්න පුළුවන් මෙන්න මේ steps ටික දාන්න. But sigma rules required. Otherwise, it is impossible. Right, then step 3. This is your model. You multiply by independent variable, then apply sigma, you obtain second normal equation. Then step 3, write down. Multiply the model by independent variable. And then apply sigma notation. We receive normal equation 2. We receive normal equation 2. We receive normal equation 2. Right. I multiply by x. This model x y x b x square multiply by x. Clear? Then apply sigma. Variable sigma x square. A is the coefficient. Take it out. A sigma x. B is the coefficient. Take it out. B sigma x square. Second normal equation. Because when you apply sigma, constant n, x sigma a sigma x sigma x y sigma x y. Only coefficient is taken out. Constant applying, not sigma. Anything the matter? Sigma rules you learn. But more than that you learn. But here, model you multiply it by x, xy, ax, bx square, xy variable sigma xy, ax is the coefficient now, a sigma x, bx, b is the coefficient bx squared, then b sigma x squared. Right, that happens. Clear? Right, then step 4. You need to take necessary data for normal equations from your data set. Right. Take necessary data for normal equations. Take necessary data for normal equations from the data set. From the data set. Then they will become simultaneous equations. Then they will become simultaneous equations. Samagami samikaran බවට පත් වෙනවා. Then they will become simultaneous equations. Right, now take data. Sigma y 420, n 668, sigma x 24, 24b. First simultaneous equation. Sigma xy 1770, a sigma x 24a, sigma x squared 106 b. Simultaneous equations. Samagami samikaran. Right. Can't you solve simultaneous equation? Right. You can before O level you did it. Right. Now last step. Solve simultaneous equations. Solve simultaneous equations to obtain intercept and slope. To obtain intercept and slope. Solve simultaneous equation to obtain intercept and slope. Right, when you solve simultaneous equation, A set off or B set off, you know how to solve simultaneous equations. That is not expected in statistics, solving of simultaneous equation. You are aware. Samagami samikaran විසඳන හැටි ඔයගොල්ලෝ දන්නවා ඕක, right? Right. That's why scientific calculators equation mode. Using equation mode, you can solve simultaneous equations. Right. Anyhow, you want to find what is the value for A, what is the value for B, then that is the best model for this data. For this data, you cannot find another model when you solve these two simultaneous equations. Right. Next week, we solve simultaneous equations. Okay, at 11 o'clock, we have finished projects. Okay. Do you have another lecture?
Yes, एकदा ते मेंटली नाही त्यामध्ये किती प्रोडक्शन हो maybe because they have learned what be the solution to overcome the issues. This behavior of the particular in which point you may choose to operate. If you take the same area, you can again. Ya, mi hacer natural, Google, porque yo lo haría. Anche nei costi sì, ඔයාට කියන්නේ ඉස්සරහට දාන්න. ඔයාට කියන්නේ මේකට ෆොටෝ මේ ග්‍රාෆ් කරනවා. But it is in production of the Western quantity. We do have. Total cost එක ගණන් කරන්නේ variable cost එකකින් ගණන්. අපි marginal cost එක ගණන් කරන්නේ. Only variable cost එකේ difference එක. Only එකේ difference එක. අපි cost එකේ දැනෙන්නේ. cost එකේ කොහොමද? Fully ගත්තත් වෙනසක් තියෙන්නේ. ඒ fix එක. Management එක තේසතින් දෙන්න තවත් ෂෝක්. ආටින් එක මොකක් කරන්නේ කියලා විද්‍යාව කියලා हमारा कोर्स प्रमोशन I Thank you.